So let's create a class called vertical slides, and then list out your states, just like other state what's it called, the servo based state machines. And then your states of the vertical slides, just think about what positions it can be in. Obviously, you have the fully retracted when it's all the way down, and then you have your chamber for when it's the slides are raised to score chamber, and then bucket when the slides are raised to score bucket. The next thing is we need to have our current state, so let's do public states current state equals states dot down. It's going to start as down. We want to have our set state method, public void set state, and then we need our input of a states new state. There you go. You guys, by the way, this is just like in the other subsystems. This is your data type, I guess, of sort. This is what you're referring to, the type, in this case our enum, and then this is our the name of it, so that way we can refer to it to the input. So we'll just set the current state to our input new state, just like every other subsystem here. And then of course get state. Data type would be states, and then get state, and we would return the current state. Okay, that's our state-based stuff. Now let's make our hardware-based stuff. DC motor. This is what we use for our what's it called, motors. What am I saying? Yeah, this just like how for servos we just let us type servos. This is the same thing here. DC motor right slide. This is for our vertical slides equals, actually we don't set it to anything, and then we just make a left slide, and then public void initiate. And we need our hardware map. And we need to set our motors to things. So right slide equals hardware map dot DC motor dot get, and then right slide left slide equals hardware map dot DC motor dot get left slide. Okay, that's actually, we might have to reverse some of these. I remember we had to reverse them because I want it to be right side dominant, so we would probably have to reverse them. Just let me just show you how to do that. Right slide dot set direction reverse, and then we would reverse the other motor too. Okay. Oh, last thing, we can also set the brake behavior. Right side dot set 0 power behavior to brake, and then left side dot set 0 power behavior, and then brake. And then we also need to have our encoder positions. I actually prefer to do it in between the initiate and the motors here. So we could do public static, make it static so we can actually change it using FTC dashboard if we ever need to. And then let's start with down position. Oh wait, what am I saying? It needs to be an int, by the way. Okay, and then we just repeat this for the other positions. For now, the values will be arbitrary. Okay, now we have our positions that will correspond to each state. Last thing we need, if I'm correct, yeah, we just need our update method. Now, here's the fun thing. We would have to use a to actually, motors use power, and these are positions. So how do we figure out how much power we have to send to the motors given our given these positions? We would use a PIDF controller to do so, but we can work on that later because that's not the immediate priority. Add telemetry to your input, and that way you can add data to the telemetry. Let's call it right slide. Oh my gosh, what the? Okay, right slide actually, you can make this capitalized if you want. Right slide position, and then comma, and then your value. So let's do right slide dot get current position. Okay, I'm sorry, I lied. One last thing we have to do. Oh, actually, let me explain what this does. So this will print out the current position of the right slide, and the telemetry on the driver hub, and it will say right slide position and then the position. So it'll be like a 0 or like 200 or whatever it ends up being. We want to have our void loop, or our update loop last. So let's do one more thing. It has to be after the hardware is initiated though. Public void reset. Let's just call that. And then what we would do is we would reset the encoders when this method is called. So right slide dot set mode reset stop and reset encoder, and left slide dot set mode stop and reset encoder. Okay, sorry for the weird cut. Anyways, with the vertical sides, we were going to use telemetry to print out the position of the right slide, and then we're going to move it to the positions we think the bug is going to be at, like just manually, and read the value that's printed from the telemetry, and then we're going to plug it in that, and then we would move the slides down to the chamber position and move it here. Also, if the down position isn't 0, what we would do is move it to the down position and reset it. So let's just code our teleop though. That's the theory behind it, but let me code the teleop. So we're not going to use any state machine yet. Instead, what we're going to do is we're going to use well, first off, let's actually initiate it, just like every other subsystem here. Initiate it, and then at the end of our loop, what we want to do is do vertical sides.update, and then we want to input the telemetry because that's what it's asking for. And the last thing is telemetry.update. You want to have telemetry.update at the bottom of your code after all the update methods of each of the subsystems run. That way all the telemetry can add up all the data, and then it can be updated and sent to the driver hub. Oh yeah, one more thing. I guess we could do this at the bottom here. We want to have the ability to actually reset our... I like to use the options button for resetting encoders. So what we could do is, if gamepad 1 to options, we don't need a rising edge detector here because it doesn't matter. But there's no like states or anything to this. It's just if you're holding down the button, then reset the encoder. So let's do that. Vertical sides dot reset. Boom. Now if when it's if the vertical sides are at the down position and it's printing out a position that's not 0, then you can 0 it by using gamepad options. And I'm just gonna say this again. Here's how we would get here's how we would get these numbers. What we would do is we would bring the slides up to the chamber position and then read the number that's being printed out, and then we'd set that number here. And then we would move it up to the bucket position, read the number that's printed out, and then set it here. That way it knows where to go. Alright, well that's all for now. Vertical slides actually, for next meeting online, we'll talk about PIDF controller and how we can actually use it to convert, basically using math, look at the current position of the motors, and look at the position we want it to go to, and it will do math and calculate the power that the motors need to go to each loop. So that's pretty cool. Anyways, I'm done.